Hello everyone, welcome to this week's news and community spotlights. We're excited to dig into the free marketplace content that's available for you all this month. To kick us off, Low Poly Viking top-down interiors by PolyArt 3D is perfect for those developing Norse-themed RPG adventures. This interior pack comes with over 400 different models for crafting atmospheric scenes. Jump in and start sifting through the huge library of household items, vegetation, weapons, lighting, and library props. Everything is fully modular, enabling you to put together the pieces in a myriad of ways to create your own unique Viking environments. Next, Lookout Tower by QuadArt. Set in spectacular scenery of brooding pine forests and soaring mountains, this lovingly crafted watchtower will make for an intriguing hidden location for players to explore. The wooded area is also playable and covers an area of 2.5 kilometers. Everything in the pack is fully game optimized, with vegetation assets offering up to 4 LODs, lighting driven by Lumen, and the river and lake powered by Unreal Engine's water plugin. You can't send your hero into the lion's den without the means to defend themselves. Fortunately, with the Adventurer's Inventory Kit by Tala as in Leekler, you don't have to. A modular design built entirely on blueprints, this inventory and equipment system enables you to quickly and easily create your own item types, including weapons, armor, documents, trade goods, and more. Next up, Science Fiction Valley Town by Scale Y. Whether your story is set on a planet far, far away, or on this one deep in the future, the Science Fiction Valley Town asset pack is guaranteed to pique your interest. This spectacular-looking sci-fi environment is powered by Nanite and Lumen for UE5 use, and comes with LODs, light maps, and collisions for those using UE4. Jump straight into the example level, complete with 4 zones including interiors, landing pads and houses, or build your own environment entirely from scratch. Lastly, Ultimate Weapon Customization System plus Stylized Futuristic Set by DunePix is a great way to empower your players to create their own bespoke guns. The system can produce over 1,300 unique weapons by enabling the customization of 7 different firearm parts and leveraging 6 skins that can be personalized to different colors. It even provides a customization widget analysis feature, offering insights into the weapon's strengths and weaknesses. Don't forget to grab this month's content fast. It's only free until the end of June. With Rivian's introduction of their second-generation R1 vehicles, it's expanding its use of Unreal Engine from the driver's display to the full infotainment center across its existing fleet. If you're interested in learning more about the process behind this new feature update, you can do so at unrealengine.com/feed. Now let's get into the community spotlights for this week. Druid by Taehoon Kim is a stunning 3D character rendering combined of the Druid concept art by Hidong Song and Druid texture work from Diablo 4 by Linyao Lee. Lovingly melded with a comfortable neutral palette is a ton of life and character, all the way down to the finest of details. The project breakdown of this piece shows off the time and attention that went into all of the levels of work, such as meticulously placed alpha hair cards, individual sculpts, mood boards, wireframe snapshots, and more. If you want to take a peek at the full thing, you can do so at their ArtStation. Dogtown Garage K9 by Hyunwoo Han is a cyberpunk modern style work and environment based loosely off of the concept by Alexander Dudar, with an experimental acrid atmosphere. Their modeling was done in Maya and 3ds Max, textured in Substance Painter 3D, and all assets were placed and set in Unreal Engine 5. Taking about approximately 3 months, this project has a fantastic breakdown of all of the created assets, lighting scenarios, and renders over time. If you'd like to see it all, make sure you check out their ArtStation. Sleepy Valley by the Team Modang is a beautiful, sprawling medieval 3D cityscape based off of the concept of the same name by Jordan Tufan. Their project shows off a masterful use of field of view to draw the eye up and along the city as it ascends further into the foggy hills in the distance, immersing the viewer in this slice of civilization that they brought to life. Showing off neighborhoods surrounding a lazy river, markets and stalls filled with colorful goods and flowers, this piece made us feel like we were taking a merry jaunt about. How about you? If you enjoyed this project, you can check out their course based on it, see a breakdown of their work, or see some of their other art over at their ArtStation. That's it for today's news and community spotlights. Thank you so much for watching, and we'll see you next time. Hello, everyone, and welcome back to Inside Unreal, a weekly show where we learn, explore, and celebrate everything Unreal. I am your host, Tina, and today with me I have some of the incredible guests that are behind the wonderful motion matching game animation sample project. We're going to be diving into it today. We're going to go through a whole bunch of stuff. They have so much incredible stuff to show you, so I don't want to take too much time with the intro today so we can get right along into it. We'll go through, we'll have each of our guests tell us a little bit about themselves so we know who you are, why you're here, why we should listen to you, all the good things. So Sam, let's go ahead and start with you. Why don't you tell us just a little bit about yourself?
Hi everyone, my name is Samuele Rigamonti. I'm a principal animation programmer here at Epic Games, and I work on physics, AI, animation for the past 20 years. And I recently focused on motion matching and procedural animations.
Wonderful. Well, thank you so much for being here. Then next up, we have Tony. Would you like to tell us a little bit about yourself as well?
Sure. Hi. Hi, everyone. My name is Tony Gialdini. I can't say my last name as well as Sam can, but I do my best. I've been working in gameplay animation for the past 24 years. I'm very old. I apologize. And yeah, thank you for attending.
Yeah, thank you for being here. And then last, but certainly not least, we have Caleb. Do you mind telling us a little bit about yourself as well?
Hi, my name is Caleb Longmire. I'm a senior technical designer in animation here at Epic and sort of the de facto lead designer of the game animation sample. Some of you may know me from the Unreal Marketplace, the advanced locomotion system. And I've been doing technical design and animation for ever since Unreal 4 was $20 a month. That was a long time ago, it feels like. So yeah, let's get into it. Let's talk about the game animation sample. First of all, what is it? It's kind of what the name implies. It's a sample project focused on the game animation, on just gameplay animation. And if you want to share my screen, I can get right into showing stuff. So yeah, the game animation sample, it's meant to be a living project where we showcase gameplay animation features. And we're going to be continuing to add to this project as time goes on. But the first release is really centered around our motion matching tool set, a whole brand new bunch of tools that make things a lot easier. And so most of you have probably seen, if you've opened up the project, we have a third-person character that can run around and do some basic locomotion. Some notable things are we have some cool turn start animations for different directions. We can have multiple rotation styles to support different kinds of game types, like action adventure or sort of shooter game types. Very basic turning in place, still work in progress. Again, everything you see is rough around the edges. We had a tight timeline, but we're continuing to make improvements. And then, of course, the character can do jumping as well as a variety of different traversal actions. And all of this is using motion matching. We're using motion matching for just general locomotion and jumping and falling, and then we're using it to blend in and out of traversal montages. Couple other things real quick that I can show you. If you click on this button, it'll open up a gameplay animation widget, which is already open for me, but this is just a small editor utility widget that we've made just to make things a little bit easier. So these buttons just enable console commands so we can show collision, show bones. We can do things like draw the trajectory. And then also we have just a very basic still cam so we can see our character running around in a different angle. And this can be really useful for just debugging animation and seeing it from a different perspective. This just changes the sort of the motion matching database LOD, and that just is essentially, we have a different database set that has a fewer number of animations. We wanted to showcase, how that might look. So if you change that to 1, you'll see fewer animations in the databases. than by default. And that's useful for, memory constraints or different platforms, et cetera. And then the last thing that we did is we wanted to showcase that these tools, this project is more than just for one character. And so we brought in as many characters as we could just to showcase runtime retargeting. So we have a metahuman, we've got, even the old mannequin, the new mannequins, just to showcase that, this is a project that can be applied to any character. So yeah, and this is just overriding the pawn that gets spawned in by the game mode. So before we dive in too deep, I just want to do a brief overview of the most important blueprints. In our blueprints folder, we have a character blueprint and an animation blueprint. The character blueprint just controls how the capsule moves around the level. All the logic for changing speeds, the traversal tracing is all in the character blueprint. And then our animation blueprint, if I open that up and just do a quick rundown. Well, this controls the animations that you see and are applied to the character. The first thing in our graph that you'll see is a pose history node, and Sam's going to dive deeper into this in a little bit. And then we have a very simple leg IK process. Right now, we don't have ground IK. That's coming soon. But this is just locking the feet to the IK bone positions. This node is super exciting. It's an offset root bone node. It's still experimental, but we're hoping that it's going to give us a huge boost in quality as time goes on. And essentially what this is doing, it's taking in the root motion from the animations, comparing it to the sort of the capsule motion, and then offsetting the root dynamically within thresholds that we can set so that the animations feel more planted in the world. And this can be done for both rotation and translation. I have a simple aim offset, simple lean additives. And then the meat of the whole graph is really this single node. Instead of a big complex state machine with a bunch of transitions and states and logic, what we're using motion matching. And so we have a motion matching node. And I think that's kind of a really brief rundown, but to talk more about motion matching and what it is, I'm going to pass it over to Sam. So take it away, Sam.
Thank you, Caleb. If you can share my screen, please. So before analyzing how motion matching works or what actually is, I want to introduce you to a tool that our KTRX implement that you can find in tool debug, rewind debugger. And what rewind debugger is basically a tool that collects a bunch of data from a simulation that is Pi, and I believe for 5.5 is going to be also using a game. And let me just enable the recording. And what this does is, as I said, records information from the simulation, and it just create this UI that is just a hierarchical view of what's going on for the character. Obviously, you can select different type of character. This is a less interesting character, but you can also see more interesting character like this one. And what this is basically, as I said, a hierarchical tree of tracks, where those tracks are bind to, like in this case, to a character blueprint. And if you double click it, you can open the editor. As you can see here, as Caleb already showed you, you go down the hierarchy, you find the skeletal mesh, and then all of a sudden you find an animation blueprint. That is the one that Caleb just showed you guys. And going down even deeper, you see that those are all the animations that has been played in the by the animation blueprint. As you can see, you can just scroll this timeline. And for instance, in this case, you see that the character was playing this box left foot, and all of a sudden it transitioned into this box right foot. And this is very, very powerful and useful to debug what actually is going on into motion matching. What we did is actually adding this additional track, that is the post-search track, that allows you to debug motion matching. But before diving into this, I want to go a little bit deeper into what Caleb just showed you, that is actually the very simple building blocks to create a motion matching setup. And in our animation blueprint, you see a pose history node. What a pose history node is just a node that collects historical information of the current character playing. And as you can see in the property, what we're doing here is collecting information from the right foot, left foot, the thighs, the spine, and pelvis, as well as you can use an input trajectory for the node, or you can let the node generate for you a very, very simple trajectory by setting it with a flag here, generate trajectory. But since we're generating a more complex trajectory with collisions, with for vaulting purposes, we actually prefer to generate the trajectory with a function that later on Caleb is going to show you how. Yeah, that's pretty much it, the idea of the pose history node, that is collecting historical information from the past for bones and trajectory, where trajectory means the capsule transforms plus the root bone transforms, as well as with the trajectory we provide the prediction. So it's the future where the character wants to go. And this prediction is from the movement model, and we're going to dive into it later. The second very important node for motion matching, aside all those procedural, is the motion matching node. What the motion matching node does is actually two things. Grabbing an input, a post-search database that later we're going to show how we pass it in, and out of this, performing a search at runtime, trying to match what's the context is, and figuring out what's the best animation to select and play. To analyze what the motion matching database is, let's use again the rewind debugger. We can open the post-search debugger. Don't be afraid, it's going to be clear what this matrix of number is. What I want you to take out of this is actually just this first row. And what the row says is that motion matching for this frame selected this animation, that by the way, you can click the link and open it at the right frame here. At this time, you see frame of time from this database that you can open it. And now we see what the database is. As you can see, a database is just a collection of animation assets. And we support different type of animation assets, sequences, blend space, anim composite, and so on. And an associated schema. The schema that I'm going to open and slide on the side here. The schema is basically what we care about to match at runtime. A schema is basically a collection of what we define as channel. There's a trajectory channel. It's kind of intuitive what it is. We have other type of channel like position channels, velocity channel, and so on. But let's focus on one of them, this position channel. This definition, what it does is actually telling the system that we care about the relative position of the left foot from the right foot. I want to show you here from the post-search database here, that is this vector here. So what that means is that for each frame of the animation, we store in the database this vector for each pose, that is the sample of the animation at the specific time. And at runtime, what we're doing is, by using the pose history information, create a query that represents the current character relative position of those feet, and try to match that. If you don't believe that this is actually the thing, you can change the color and see that this is actually the associated channel for those debug lines. But this is basically the gist of how motion matching is working in Unreal. Yeah, I'm gonna hand it over to Caleb to show you how we actually set up the selection for the post-search database for the motion matching node.
Okay, but before that, I want to hand it back. I want to hand it to Tony to talk about how animations, how we actually set up our animations and what to think about when creating animation assets. in order for motion matching to work. And before Tony takes over, unique thing about our project is we're entirely capsule driven at the moment. And we had to do it that way. There's a number of reasons. One, it's easier to network. It's hard to run animation on the server on a large multiplayer game, just too expensive. And so being that the character is capsule driven and the animations themselves don't have authority over the motion, we had to get really smart with how the animations were authored to make sure that the animation data closely matched the movement model data, so that when motion matching did its query, it knew what to pick. So more about that, Tony can take over.
Hey, so yeah, kind of just springboarding off of what Caleb said, we didn't have to go, but we went with a capsule-driven motion. For root motion, it's pretty easy. What you animate is what gets called, what gets analyzed, whereas we had to have kind of more restrictions, how quickly it had to change exact speeds. In our motion model, actually, there's varying speeds. You go faster forward than you do to the left and right, and then you go slower when you run backwards. And so it's not all a consistent value. And so we had to figure out how to get all of those different values, all of the different shapes, all of the different directions you could go. And so we broke them up into shapes. But to get as close to the game as possible, this is just Maya, we actually exported the mover's motion from the game by playing it. So do the exact shape at the exact time, get precise movement. So it's just as mechanical as possible, as kind of just exactly what the game is going to see. We break down that motion, and so here you see it's just a motion path on an actual exported motion. I just have a big locator here to show that this is the exported game motion, and then you see the bones of the character on top, basically running the same animation that we were just looking at. And you can see this is going to be a right foot plant off a different loop into the next loop. We have some steps of the loop baked into the animation so we can see the transition ourselves. And so we know that the frames we're picking are exactly close to the pose, like what Sam was showing you is as close as possible. But as you can see here, the animation is following the capsule motion exactly. It's within a tolerance when you're talking about it's in other games that I've worked on, you either lock down the hips or you lock down the chest. I prefer to lock down to the chest because then you get all your nice weight transfers and all your nice weight shifts. You can see here as he steps out, we allow him to go a little bit forward, a little bit backwards, actually have more weight shift in there. And so what this allowed us to do is take our motion capture data, take our motion data, and marry them together to have them be as close as one-to-one as possible. So then when we got to the game, I knew that as this animation played, it was going to perform exactly as the game was requesting. And so that just kind of helped a lot with our selection. Is this an animation problem? Is this a system problem? It simplifies it quite a bit. And then kind of another issue that cropped up is what I'll just call superhuman motions. And so our stop animations, due to the speeds and due to the braking distances and when you have to come to a stop, we have to stop within 5 frames. That's very, very, very fast. And so we came up with this system basically that when it stops, when you see here the character stops, we allow the character to overshoot then. So the capsule motion is still that 5 frames, slams to a stop. We have no more root motion. But then the character has momentum where they carry through. We have the feet continue to step back, and then we have it resolve to idle over a little bit of time. But we just made sure that those tolerances, same for the move, stays the same here, where it doesn't get too far away from your capsule motion, but we allow a little bit of shifting. So now you can see it's under the chest and a little bit under the feet. And this just allowed us to continue that flow of weight. And even though it's all capsule driven and it's just kind of stuck to this, we still got all of our nice overlapping motion. We get all of our weight transfers, and motion matching has a lot easier time selecting. And so we have all of our different stop animations. They all stop within that same couple of frames, but then we have all of our different stops on our different feet. They match all the phases, and then just everything flows together a lot better. But speaking of that, I'm going to pass it back to Caleb to talk about, in the motion matching database, how to send that up and how you would use choosers to kind of refine the selection so you get even closer and have greater fine detail control over what animation is selected, when, why, and at what pose. Caleb?
Yeah. So real quick, regarding root motion, capsule-driven stuff and all of that, we are actively looking and improving a lot of those things. One of the reasons why we couldn't use root motion now is we're still using the default sort of character movement component in Unreal. It doesn't handle root motion very well at the moment, but it's going to get better very soon. And so those were just sort of the constraints that we were working with at the moment. But as Tony said, we did a ton of work to make sure that the animation data and the movement model data matched as close as we could get it. However, there's a lot of instances, there's a lot of times in games, surely, where designers want to have control over the animations that are being played at any given moment. And it's tempting to take all of your animations and throw them into one big giant database, and it'll get you 60, 70% of the way there very, very quickly. But then when you need to start refining that and say, like, I want to play these animations at specific times, we found, and those of you who have used motion matching before may be very familiar with this. If you tune a little bit of, tune some weight values in the schema for one thing so that the stops feel a little bit better. Well, now the starts don't really select as much, and it's sort of this tug of war back and forth. And so what we did essentially is we split up all the different kinds of moves and all the different kinds of movement states into different databases. We have our jumps, we have our lands, we have our idle, stops, runs, walks, and then even different, the different kinds of runs, the loops, the pivots, etc., all into different databases. And that's important for two reasons. One, it allows us to have a different schema for each database if we choose to do so. A lot of our databases use the same schema because we've made sure that the tuning of that schema worked for the animations that we had. But some of the animations, such as the stops, if I find a stops database here, there we go. You can see that it has its own schema. We have the stop schema just for the stop animations, because for stops we felt, or we found when playing, we needed the trajectory to be weighted higher than in normal locomotion. And so splitting up things into multiple databases helped us get more control over the motion matching selection. But how do we select from all these databases at runtime? If you go to the animation blueprint and look at the motion matching node, there is a what's called an anim node function, which is a function that gets tied to the node itself. There's an on update, and there's a on motion matching state updated post selection, essentially. The on update function evaluates every time the node updates. So every time this node is ticked in the graph, this function will be called. And what this function is doing is we are evaluating a chooser and then outputting an array of databases and setting the databases that motion matching is allowed to search from that array that's output from the chooser. Then we have another thing called an interrupt mode, which I can talk about a little bit, but I want to show the chooser first. But before I do that, there's a couple other functions that are important in the animation graph that we're using in a lot of places in the chooser. So update states, what is this? Essentially, what we're doing here is we're taking all of the important states that the capsule can be in, how it moves around, and we're just caching them into easy to use enumerations. So we have our movement mode. Are we on the ground? Are we in the air? Our rotation mode. Are we rotating toward the direction of movement, or are we strafing, which means sort of rotating toward the camera direction? Our movement state, and this might be a little bit confusing, but essentially it's just saying, is the capsule trying to move, or is it trying to stop? Is it moving in the future or stopping in the future? And then our gait, which is, are we walking, running, and sprinting? And then our stance. And this is coming in 5.5. Crouch is not hooked up yet. And so now that we've done all of that, and we're also caching the last frame's values, and that allows us to know when those states have changed, all these states can be fed into the chooser table, which I'll show in a minute, in order to select the databases that we want based on the states that the character is in. And so if I just do a quick playthrough right now, you can see as soon as I hit the walk button, motion matching will immediately go into the walk databases. As soon as I hit the run button, we'll go back into the run databases. And if we don't have things split up into multiple databases and controlled through a chooser, sometimes motion matching can hang out in an animation for longer than you might want it to. If I start running, it might still play the walk animation for a little bit longer before transitioning to the runs, or vice versa. And so, as a designer, we know, hey, when the capsule leaves the ground, I want to play the jump animation immediately. I don't want to hang out in the locomotion animations any longer than we need. And as soon as the capsule hits the ground, we want to play the land animations. So the movement state enumerations that we're saving here allow us to do this. And then secondly, and why don't I just go to the chooser first? So if we open up that function again, look at this chooser. The first thing that you'll see is what I mentioned earlier with the gameplay widget. We have a little LOD, which just chooses whether we want the dense databases or the sparse databases. In this case, we're just looking at the dense, so we can open that up. And this is sort of our main chooser table that picks what motion matching can currently look at. So all of our main states you can see here. And then these are what's called nested choosers. So it's sort of a sub chooser nested within a row of a chooser in the same asset. So all of our on-ground standing idles can be found in here. All of our on-ground standing, moving walks are in here. And if I open up these, you can see that we have an additional bunch of rows for additional selection. And we have these values here: is starting, is pivoting, just traverse, just landed, etc. All of these are just simple getter functions that you can find, and I call them movement analysis functions, and you can find them in the animation blueprint. And so is moving, essentially, is my future velocity and my current velocity greater than 0? I must be moving. Am I starting? Is my future velocity greater than my current velocity within some threshold, and I'm moving? That means I must want to be starting. Pivoting. Is my future velocity and my current velocity moving in a very different direction? If so, I want to be pivoting. And we're doing all of this so that we can filter down even further what motion matching is able to choose from to get maximum control over the motion matching system. And so you can see that our starts are only true if starting is true. Our loops, we pretty much keep active all the time unless we just landed and we want to play landing animations. And all of that works together to really give us more control. And then the last thing I want to talk about before I pass it back to Sam to go a little bit more into debugging is the concept of continuing pose. So what continuing pose is, it's a negative cost bias that we apply to the currently playing animation so that motion matching is more likely to pick the next frame of the animation. So if it's currently playing an idle animation, it's more likely to continue to play that animation based on that continuing pose bias. And that's something that we apply in our databases, but also we have tags that you can apply to certain frames of the animation to sort of boost the continuing cost bias in those frames. The issue sort of with that is if everything is in one database, like I said before, like say like the idle animation has a really low continuing cost bias, which means it's more likely to keep playing. When I'm in the idle animation and I go to move, I want to play start animations, but the cost, because the continuing pose cost bias might be too low that it doesn't play the starts until too late. So we have this concept of an interrupt mode, which is something that we showed here. So if we change the databases that motion matching is currently able to choose from, we're not guaranteed to switch to those databases automatically based on the interrupt mode that we have here. So by default, we don't interrupt motion matching. We allow it to continue to do its thing based on the continuing pose bias and the other weights. And so even though the databases might have changed, it might continue to play that animation. And that could be good for a number of things. Let's say that we have our start databases that's active for just a couple frames when we begin the motion. So we start moving, our start database is active because we're accelerating. We've picked a start animation, and now the is starting condition is no longer true because we've got to a constant speed now. Well, in the chooser, the logic for that database might be false, but we want it to still play that animation because it has a continuing pose bias. We want to allow motion matching to continue to play that animation until it gets to the cycle. And so in those instances, we don't want to interrupt motion matching when the database is changed. We just want to leave it, to do what it does. In other conditions, though, and if we open up this function, you can see when we're actually choosing to interrupt the database is whenever those main states change. So if my movement mode and my movement mode last frame are not equal, that means that this frame, my movement mode has changed. So maybe I was on the ground and now I'm in the air, or in the air on the ground. Or my gait, was I walking and then I'm running? Well, my gait has changed and I want to interrupt motion matching. And so this helps to keep, like I said before, it helps to keep motion matching responsive to the changes in gameplay states. And so those are sort of the key pieces that have allowed us to gain more control over motion matching. Well, let's talk about debugging. And for that, I want to pass it back to Sam, who's going to, walk us through the whole suite of debugging tools, because this can be difficult because there's no state machine, there's no graph, it's hard to follow. So take it away.
Yep. So first of all, I want to add one more thing about the continuing pose. That is, when you're searching from a motion matching node, what's really happening is that your motion matching node is still in, let's say, in the previous, is playing the previous animation. The previous animation that comes from, let's call it a previous database. And the current frame, what you're telling the system is, well, now try to search also from this set of databases. What the motion matching node will do is still search the previous database and search the new databases. Biasing the previous databases basically implied that we're making the situation, the previous animation gets kind of like sticky. And that's why we want to have these interrupt modes to make sure and clear up the previous playing animation out of the node, out of the system, to be able to search only the newly provided databases. But it's complicated, but what we can do here is, now I'm going to show you how to debug this system. And let's first of all, let's record a couple of frames. Let's see, and pause. What I just did is basically just play a little bit, populate this rewind debugger tracks. We're going to open the post search debugger here. But first of all, you see what's happening here. This is the currently playing animation, and this is actually what Caleb defined as the continuing pose search. That is basically what would have happened if the system continued played the previous animation. In this case, I believe is exactly the same, since you can see from the rewind debugger, we are actually playing this animation. So for all those frames, as you can see, this gets updated. Motion matching is actually going through this animation without basically doing any additional search, because it doesn't have to. And that's the only animation that we're playing. But let's go to a more interesting frame, that is like the first frame when we selected this animation. And by the way, you can also you can use the slider here to move frame by frame, or you can use the arrow key in your keyboard to move frame by frame, and that's very handy to actually find the beginning of when this animation played. And
also, if you eject the camera, you can actually follow the character and it will replay what you've done. I don't know if that's doing it there. But...
Thanks, Caleb. That's actually very useful.
Why would you want to see that?
Yes. So now we can actually see what really happened. So what I'm doing now is actually going at the moment where motion matching node selected this new animation and trying to understand why it did that. As you, let me see, no, this wasn't this frame, it was this frame here, exactly. So what happened here is that we were playing this animation here, as you can see here, and now all of a sudden motion matching chose this animation here. That is the active pose now here. Obviously the selection happened because the cost of this new what we call pose, that is basically an animation at a specific time, is better than any other pose. What I didn't mention before is that all those are the options that or poses that motion matching evaluated. You can actually see basically your coverage, your analyzed coverage here. With Control A, you select them all. And you can compare against all the other options here. So let's have first of all kind of a geometric idea of what's really going on. So let's disable all the poses that motion matching selected, and let's just analyze what is the query. So as I mentioned before, the query is something that motion matching composed by using the pose history node, so aware of whatever the historical position of joints, bones of the character and trajectory as past and future, and it composes by following what the schema tells. I want to remind you that the schema was telling that we care about the distance between the feet, the velocities that here you see in purple, and the trajectory, where the future trajectory is those blue points where there's some velocity components, some heading components, and so on, and the past trajectory that right now we just care about a short bit of the trajectory in the past that you see here in red. And so this is the query. This is where the motion model wants to go. That means now the search is find the best pose out of the database of databases that is the most continuous pose out of this pose of the character that you see on the screen that follows the trajectory that I want to go. And what he found is something like that. You see, it's not exactly the same one, but it's the best one. That if you see the other option, well, they're all worse than the one we saw. Okay, so that's pretty much how motion matching works. That is trying to score, given the current context, current geometrical context, and historical context of the simulation in Pi in this case, composing a query and try to match that query against whatever database poses you have. But let's do a deeper dive to trying to understand how to debug this and how to bias those things in a better way. So obviously the most important thing is the cost, but how is the cost calculated? To give you again the geometrical idea, you see that the distance between the query, that is the one we're seeing here disappearing, and the selected result is kind of like, let's say, I don't know if you can see my mouse here, but what I want to show you, like the cost is basically the distance between this point and that point, plus the distance between this point and that point. And the same goes with velocities, like it's the distance between those two velocities and so on and so forth with all those channels that we put into the search. And so ultimately, when we come up with is a total cost that is the sum of all those errors. And that's how we calculate the global error. If you want to do a deep dive and be prepared, because there's going to be a lot of numbers, you can actually look at the channels breakdown that is going to show you all those numbers. So for instance, in this case, we see, for instance, that the channel that we're analyzing was, those are the trajectory, and those are the pelvis, and we have the feet velocities. And I believe this one was the one we care about, that is like the left foot against the right foot. And we see that there's different candidates at different costs. But being not the main component for the search, well, we have to weight it against other channels. And to do this weighting, if you open the database schema, I'm just going to go from the link from the post-search debugger to the database, and from the database to the schema, you see that every channel has a field, a property that is the weight. The weight is basically the relative importance of channels between each other. So in care, Tony mentioned, or actually Caleb mentioned before, that for stops we care more about the importance of trajectory. Well, if you care more about the importance of trajectory against the continuity of the pose, what you can do is increasing this weight number. If I put 10, most likely what I'm going to end up having is a motion matching that is going to select an animation that closely follow the trajectory, but it's not going to be as continuous for the pause. Obviously, to mitigate this problem, you just add either more data or you kind of like manipulate a little bit more your query. But that's basically how motion matching works and how you can bias towards situation when you have a lack of data. I'll give you a simple and silly example. Let's say that you have a database with only 2 animations, an animation that goes forward and an animation that goes backward. That is very, very low coverage database. And now your query says, well, I want to go left. Both options are terrible. Which one would you like to pick? You see that this becomes a design decision. And through those weights, you can make that decision. Let's say you want to bias going forward. So you want to bias those channels, like for instance, a velocity or some sort of heading facing forward, that is going to make you select the forward animation rather than the backward animation. And that's pretty much how we tune this entire system, by analyzing this grid of numbers, figuring out mainly why this animation is picked against some other animation. You can have a geometrical representation. You see pretty much that, you know, they don't match, or it was obviously the best one. And in case you're uncertain, well, you go down the numbers and you figure out what the weight associated to specific channels are. And so you can tune it. But this tool is also working not just for the motion matching node. We also have a motion matching function that can be used not just in the animation blueprint, but also in the character blueprint. And we use that for situations like vaulting that I think Caleb wants to talk about.
Sure. Sounded like an E3 demo, all this back and forth. Totally unrehearsed.
Did I have a fake controller?
You're right. Okay, yeah, so for locomotion and falling and in the air, jumping, motion matching every frame works pretty well because who knows what the player is going to do on the controller. We want to keep motion matching responsive, so we're doing a motion matching evaluation every frame, picking all sorts of poses. But a lot of times, gameplay is made up of, you know, the character does a specific action, and a designer says, hey, I want the character to perform an animation at a specific time, you know, one animation. So how can we use motion matching in that scenario? Montages as well, right? You know, a lot of our gameplay actions use montages because we can get root motion, and we can use motion warping to warp that root motion. And that's sort of the meat of our current traversal system. We play a montage and warp it to the right points, like you see here. So if I open up in the character blueprint, there is a tiny little function called try traversal action, which is totally not daunting at all. There's a lot of nodes, but I promise it's quite simple. This is the function that just does some checks on the environment to find points on these ledge objects that we can do traversal actions on. And I know there's questions about, are we going to make a fully dynamic traversal system, you know, all of that. I love fully dynamic traversal systems. I think they're great. But for this demo, we had a tight timeline, and for simplicity's sake, we decided to just tag up some obstacles with spline points so that we can more easily find points on the ledge, and then also prevent the character from doing actions on the corners, so they were always a set number of units in. So that's why we're using sort of the spline points. But this function just basically traces forward, does some finds points on the ledge, traces over it to find the ground locations. And actually, just a fun little thing, if you enable this button, Traversal, on the game animation widget, you can see those traces happening and all that stuff that you can debug. I missed it there, but there we go. So that's what this function is doing, essentially. And at the very end of that function, you can see we have a motion matching node. So what this is doing is, after we've done our sort of evaluation of the environment, we found a ledge that we want to mantle onto, and we're actually also using a chooser here to further filter down the kinds of animations that we can select from. So based on, let's see, if this is a vault or a hurdle or a mantle, we can choose different sets of montages. And if you open up that chooser, you can see just that. We have all of our hurdles here. We have all of our vaults. Based on the speed, the obstacle height, the obstacle depth, all of that, we can choose different montages. And this is great so that designers or animators or gameplay programmers can make very explicit decisions on what kind of actions can happen in certain cases. But after all of that, and after we've got the animations that we want to search from, we still need to do things like pick the right entry frame based on the distance to that obstacle, or based on the current pose. We might have a left foot or a right foot version of that climb animation, and we want to pick which one to play based on the current pose of the character. And so that's where motion matching comes in. We can see that we take the output of all of those, or the output of that chooser, we feed it into a motion matching node, and that will give us a result. It'll give us the animation to play. It'll give us the selected time, essentially the start time of that montage, even the play rate, if we want to allow that sort of thing. And you can see that, motion matching is more than just for locomotion, doing it all the time. We can use it wherever we want in any gameplay ability we want to do sort of that final bit of selection to really increase quality. After designers do their own selection based on, gameplay, we can say, pick the right frame of this animation based on pose or speed and all of that. And I think Tony wants to talk a little bit more about our traversal animations and how we animated them and sort of the thought processes there. So again, I want to pass it back over to Tony.
Thanks, kid. Yeah, so I mean, I've worked on many traversal systems, and always the question when you start is how many things dynamic can it go up, like how many different objects can I build and stuff like that. And so that's kind of per game. So we had to start with what made the most sense or something as an example that kind of would touch on as many things as possible. And so what we kind of landed on is the way I break up my traversal motions. As you can see, this is a climb that launches off the left foot. I pick it based on where you land. So this is kind of like a mantle because you land higher than when you started. And then there's hurdles where you actually land on the same surface as where you left. So you're hurdling over something, or it could be that you're standing in front of it and you still have to hurdle over it. And then vaults are in a situation where you don't know where you're going to land. So you're going to do the motion, and then I now have to fall past. So now there's all this extra animation of falling past, and maybe there's a ground or, later on when we add ledge catches and stuff like that, it's it can become this thing that can just keep exploding with data. It's just how many different motions do you want to support? And so we just wanted to make sure that this supports as many as possible. So you can see here we have the simple connect joint that shows the ledge. We have, animation. So here's a run coming in, so we know, where it's coming from, the speed it's moving at. It's moving at the exact same run speed. And then when it's ending here, it is ending in the fall speed. And so kind of the same thing for, if we go back to a mantle, here's a stand where you can see it's right in front of him. We make sure that we're measuring the distance between which foot, because you could be coming to a stop in front of something and then decide to mantle. And so this just ends on top. You have the left foot launch. We will have, or that's right foot launch, and then we have left foot launch. So there's a walking one where it starts and ends in the walking speed. And kind of another thing that just goes down to is just the flow of it, how quickly it reacts, because you have to take responsiveness in, and responsiveness versus how many different motions you want to make. Harkening back to what Sam was showing you guys, there can be an infinite amount of trajectories in going in an infinite amount of directions. If you have a controller, there's every single degree of angle. And so you pick the most likely to fill in with as much data. And so for our dense set, we would pick as many different motions as we could. So, I mean, just looking at the pivots here, here's all the different pivots for all the different directions. You can see this explosion of people running in different directions off different feet at different speeds going. Yeah. And it can get very dense very fast. And so it was kind of tune that down into things that were digestible and things that you could see and things we can all just understand why, because you don't need all of this. This is to kind of show at the other extreme end of this is full coverage of all your different motions, all the different directions it can be going, all the different speeds, but you don't need all of this. This can be tuned down for your game. So the way I like to start is you start with everything, prune out what you don't need, and you can go to a sparse set, something that works for like a either like a mobile platform, Switch, something else, something that's not a not a PC, not like the most powerful thing in creation. But figure out what you need for your game. Figure out what works for you, what coverage you need, what motions need to be supported. And so that helps you to start from the densest set, start paring down. Mirroring, you can mirror different motions. So you can get like, oh, I have this left foot pushing off in this direction. It's like, now do I need to make the other direction? And then all the other 45s, it's like, no, because if you mirror that, now you have a left foot or a right foot push in the other direction because it's mirrored. Yay! And so you can use that for memory constraints, object creation constraints, just how many animations you want to create. So you're not spending years and years just making every single thing you can think of. All that is here for you to kind of like look through and see, like, does this get better if I add all these motions, or does it look the same? Is there a quantifiable difference of, yes, I want more of this, or nah, move on. So to kind of, showing and debugging like how we design for traversal, Sam shared some of that, but let's show like how does that work in the traversal sense of measuring the distance, measuring the height. So Sam, you want to show us how to debug that?
Sure. If you want to share my desktop. So I have Pi here running. Let's just record a couple of frames. Pause. By the way, forgot to mention you can pause from here, or you can pause by using the pause button on your keyboard. I like the pause button on the keyboard.
I don't have one of those.
Oh no.
Slacking.
No, my keyboard doesn't have all the keys.
Let's move to an interesting frame, as usual, to debug things. Actually, first of all, I want to show you, as Caleb mentioned, we're using montages to do traversal action. And again, in your very useful rewind debugger, you could see that. Here, basically, we know we were in locomotion, doing stuff, and all of a sudden, we select montages here. And at this point, we start playing this montage. And let's look at the montage, first of all. What you can see here. Obviously, you see the motion warping notified state. That is the one that we use with the warping features to make sure that we have a detailed alignment by the time we hit the object. And also we have this post-search we call it branching notified state that basically let the motion matching system know what are the frames of this animation that we care about to index. So we know that all those frames here are not going to be used by the system to select as a starting frame for the traversal action, only those ones. Let's open our post-search debugger at the right frame of when the traversal starts, so we can actually see what's going on underneath it. The first thing you see in this case is that since we have two providers of information from motion matching, we have the motion matching node that you see here was doing his locomotion stuff, the usual thing we saw before, different candidates analyzed, and so on and so forth. When you have multiple sources of motion matching data, you see this button appearing that basically allows you to go back to this view. And we have here the traversal, that is the data that is coming from the function that Caleb mentioned, from the character blueprint. The traversal function doesn't have a continuing pause because, well, it starts with no context whatsoever. And it analyzes this database that contains a bunch of traversal. As you see in this database, if I select them all, give me a second. Okta decided to, apologies.
What, you didn't think this was the perfect time to like reconnect to the VPN? And
I don't know.
Oxus seems to think this is the perfect time.
No, I think it's the DDC security
Oh,
thing.
got it.
Yeah. And now I'm all authenticated.
Now he's secure.
Excellent. We're back. Those are all the frames that we index in this database that we use to do this kind of action, this traversal action. As you can see here, what we index is, yes, as always, a bit of trajectory, and maybe I'm going to open the schema for you guys to understand a bit more. We check against the trajectory, we check against usual things like positions, or let's call it the pose continuity, like what's the phase of the feet and so on. We decided to use the relative position between the feet, the velocity, and so on. But we also have two interesting channels here that are this one and this one. And what those channels are basically extended channel in Blueprint. Let me go where they are, and we're going to look at them first before analyzing, so we have a better understanding on the entire picture, how things really work. Oh, by the way, how to create one of those is just, as always, you open your Blueprint class. You know that is maybe a position channel, the one you care about, and you just extend it the usual way you would with any Blueprint class. And what those channels do when extended by Blueprint, and let's open one of them. No, they are not those. Here. What they do, they allow you to override the function. This function, what it does is just providing a position at query time. I remind you that motion matching works by constructing a query from the motion matching node or whatever, and use that query to match the best pose out of a database. So this function is used at query time to figure out what's the position that we want to match for the ledge in this case, like the position of the obstacle, and for the other channel that we're using, the heading. And this channel overrides another function that is called get word rotation that provides a rotation. And to give you the geometrical understanding of this, again, let's go back to the database. And let me open again the schema, maybe on a separate window. You see that those channels are the blue and the yellow one that are exactly this point here. Oops, terrible at navigating, sorry. So for every frame, what we mean by applying those channels is, for the blue one, is the relative position of this point that is our interest bone in trajectory space relative to the root, as well as the relative orientation of this point relative to the root. So let's go back to our pi analysis so we can figure out what's going on here. So at this frame, we select our traversal, we selected this frame. So you see that the query that I just show you how it gets created by those channels, and by grabbing the position and orientation from this ledge here, gets constructed and gets matched against all those options. And out of those options, we selected this one. That is not exactly where we want, but is the most precise one. And so what we have to do is leverage on the warping behavior to mitigate this error and this orientational error within time, within the warping window, and apply it to be able to reach, let me close here, to be able to reach the point at the right time with enough precision. And I hope this is helpful, and I think that's pretty much it about how to debug this system. That again, I want to do a quick recap with all the pieces that motion matching uses. So we have a pose history node that contains information about the character performing in your simulation. We have a motion matching node or a motion matching function that they use the pose history node to compose a query. And this query gets matched against similar poses from a database. And we pick the best pose out of the database that a chooser provide. And by the way, if you wonder how to debug a chooser, you can just open the chooser from this track, and you would see this UI, and maybe we can dive into it maybe later. And so the chooser provide the database that gets searched, and you basically have the best one, and is the one that's gonna get played next by the animation blueprint in case you're using the motion matching node, or you provide it to a node like a play montages from your character blueprint, like we do for our traversal system. But I think now Caleb wants to show you something cool about how to extend the system.
Yeah.
So it's on.
So I'll try to be quick here because I know I want to get to QA because there's a lot of really good questions in the chat, but we thought it'd be fun. So the best way of learning is really by doing. And so what better way than to extend this to, extend what the character can do to some new stuff. So crouching wasn't, it's not implemented right now. It's coming in 5.5, but what we did do is we included all of the work in progress crouch animations into the project, except for the idle animation somehow. I'm really sorry, they got omitted from the build. So one of the most important animations is not there. But we have all of our crouch animations that users can work with. And so I thought it'd be fun if we just do a quick rundown of how to add crouching or something like crouching to our system. So the first thing we want to do is just make sure that the character can crouch. So if we open up the character blueprint, I just have this unchecked by default, but if you check it back, hook it back up and compile, if you hit the C button on the keyboard or the B button on the controller, the character will crouch, and you can confirm, you can look at the collision, you can see the collision gets smaller. But of course, no animations are being played right now. And if we escape, we'll actually get a little warning, no database access provided by motion matching. And if we look here in the chooser, and that's because, well, our stance is, we only have stuff for stand, not for crouch. So to speed this along, what I've done is in our motion matching databases, I have put together a bunch of different databases that are currently empty right now. I just duplicated these databases and renamed those from the runs, and we can start populating these databases with animations. Unfortunately, we don't have an asset browser right here, right now. That's coming very soon because it's super handy to have an asset browser in the database. You can just drag animations in. So I'm gonna have to go to the animation blueprint. So this crouch idle loop, like I mentioned, we didn't add, somehow it got omitted from the build, it wasn't referenced or something. And so I just took a pose from one of the crouch, or from one of the stop animations, duplicated the animation, cleared out all the other frames. So I just have these frames where the character's doing nothing. And that's gonna be our idle loop for now. I'm gonna throw that into the idle database. If I open up the loops, I'm gonna grab all of the loops except for the crouch idle. Throw that into our loops database, open up our pivots, and throw our crouch pivots in there. Nope. Pivot. And then starts. Bear with me here. That'll be fun just to do it live.
Absolutely.
Crouch starts. And I think there's also a problem with one of these animations. I think it's the start forward right foot has a section at the end where the character moves away from the root. So apologies about that. That's going to be fixed in 5.5. But for now, I think I'm just going to remove it from the database. Or
I already fixed it.
oh, you already fixed it. It's already fixed. What also you can do is you can just disable animations from the database, so you don't have to delete them. That's really fun. And then our stops. Let's see, crouch, stop. Alrighty, throw this into the stops database. I really should be saving my assets here. I usually don't go this long without saving. And now I'm nervous that there's going to be a crash and we'll lose all of this.
Like in a dangerous game, Caleb.
Okay, everything is
rolling
saved.
them bones.
Alrighty. All right, well, I've got these databases set up. Next thing to do, remember this function in the animation blueprint where we're updating all of our states. I have the stance, and I've already done this just so that users could get started quickly. So I have the states, crouch and stand, that's ready to go. So in my chooser, I can begin to add some additional nested choosers that contain our crouch animations. So the first thing I'm going to do is I'm going to do a new nested chooser, and we are going to call this, we're going to new nested chooser crouch idles. And then we're going to make another one nested chooser, and we're going to call it crouch movements. And so in our idle, edit this, I'm just going to throw in our idles database for crouch idles. And then in the movement, for now, I'm just going to throw in my loops. We'll see how that looks. If I save, and fingers crossed this works, totally might not, we'll see. If I hit the C button, nothing. Okay, well, that's not good. No database is provided for motion matching. Oh, I didn't. Duh. I didn't actually set up this logic. So if we're on the ground and we are crouching and our movement state is idle and we don't care about the gait because we don't have walk, run, etc. for crouch, we just have crouch movement. That could be any. And then if we're on the ground crouching and we are moving, we'll be playing those. So now if we try it, just crouch, boom. We don't have any transitions right now, so it's just going to be a blend. But if I'm moving around suddenly, crouch animations play. And so that was really, really fast. Just throwing animations into some databases, getting them set up with some choosers. But you can see that there's more that we want to add here to get higher fidelity. And we can start doing that very quickly. So for our idles, something that we did that might be a little bit confusing is we have a movement state here. Right now, that's just idle and moving. It doesn't say like stop or pivot, etc. And that's because in general locomotion, there's kind of two kinds of animations. We have cycles and we have transitions. So a run cycle, we know what that is. A start animation, maybe a run start, that's just a transition to a cycle. An idle animation is also just a cycle. And a stop animation is just a transition to the idle cycle. And so if we know sort of what the character wants to do, like do they want to be moving or do they want to be idle, that can be the state. And then those transitions, we can just figure out if we want to be playing those based on some almost like entry conditions. So the stop animations actually live within our idles category because they are transitions to idle. So if I add a new asset here, we go crouch stops. And then for this, what we can do is we can just give us a float range and we can say based on the character's speed, if my speed is above, some certain threshold. And right now we don't have sort of expressions for floats. I think that should be coming soon. So basically when motion matching looks at this, or the chooser looks at this and says, if my speed is below a certain threshold, play my idle animations. If I'm entering into the idle state, meaning I'm not moving in the future, and my speed is above, 10 centimeters a second, I should play a stop animation. And if I save that, and then I crouch, and then I stop, might be a little bit hard to see, but we're actually playing stop animations there. Got all that settle and that weight shift. And so just like that, we've got that transition animation working. And then if I open up my my movement, I could throw in my starts and my pivots. And then I'm gonna just add some logic here. So if the character is starting, then that should be true. And if the character is pivoting, then we want to be looking in our pivots database, and so that can be true. So now in I don't know how long that was, maybe 5 minutes or so. It's still rough, but we've got our pivot animations for crouch. We've got our stop animations, our start animations, um, all working really, really easily with motion matching. And so, yeah, that's just sort of a quick live demo to show you how this system can be extended. Um, and I guess with that, we can move on to Q&A,
Awesome.
right?
No.
Yes.
Yes, absolutely.
Okay. Oh, wait. Huh?
None of you get questions. Just hard cut. Stream is over. All right. Let me pull these up. All right, so I figure the way that we can handle these, I'll just verbally ask them to you all, and whoever wants it can have it. We'll do just a free-for-all, kind of rapid fire through them. All right, so to start us off, how do you guys think the motion matching system will work on a smaller indie scale? Say if you're currently using a multitude of different animation packs to apply different additives, locomotion, etc. It seems like the system doesn't perform as well with a smaller animation sample, whereas a system more similar to what was built for Lyra works really well for that.
I'm going to take that question because this is something that I really want to push on in the future. I love small animation sets. I love doing more with less. And before I used motion matching, I loved using state machines because it gave me total control over what was playing at any given time. And so something that we are going to be looking for in the future and working toward is a workflow that gives you the entire spectrum of animation selection, from the high level stuff that you can do with state machines to sort of the low level stuff based on pose and trajectory with motion matching. So to answer your question, motion matching can be used really however and wherever you want to use it. So even in a traditional state machine setup, you can use motion matching on just the transition to pick, say, the entry frame of your stop animation or the angle of your start animation. And that's something that we don't have showcased here, but I'm really passionate about that, and I want to showcase that soon, even if it's experimental. So hopefully that should be coming in a future release, sort of showcasing how you can bring motion matching and state machines together to give you that sort of whole spectrum of selection ability. So yeah, hopefully we'll see more of that small data set stuff in scale in the future.
It's kind of like a misnomer that you need all coverage. You don't need the huge dense coverage. It's just the way that it's selecting poses and stuff like that. It's just kind of a more intelligent way of selecting your into frames and stuff like that. So it's not just like animation start here, play. It'll decide like, hey, it's better to blend from frame 5 versus frame 1. And so it's not restricted like this is only if you have a team of thousands making tons of animation. It's just
or one Tony.
You can also add, in case you're doing a comparison between, like, let's say, motion matching and blend spaces, where blend spaces are basically synchronized animations in phase. Somehow you can put blend spaces into motion matching and just sample, let's say, your cardinal direction, and all of a sudden an answer of motion matching is one of those cardinal direction, and then you can procedurally manipulate the blend space that has been selected. That kind of resemble the idea of using like an orientation warping kind of idea. So obviously it's not a silver bullet, but motion matching is something that allows you to do selection, contextual selection, given the context of the pose, future and past trajectory, and so on. And it allows you to add more data after. And that's the cool part, because ultimately what I described, you can have a kind of motion matching setup with blend spaces, but all of a sudden you want to add pivot, and now you can, rather than with the blend spaces would be a little bit more difficult.
Yeah, absolutely. I do also want to make a super quick comment. We also have Jose and Patty that are in the YouTube chat. So if you answered a question and we don't answer it verbally here, it's probably because those two have been going absolutely ham in chat, and I've been answering a lot of them there. So the chat will also be preserved with this stream, so you can scroll through and find a lot of answers to questions in chat later as well. All right, next question for y'all. Is it efficient to use motion matching for NPCs and enemies, or should it be limited to playable characters in terms of best practices and performance?
I can take that one. So consider your original setup. again, most likely you're going to end up with a blend space or something similar, like a state machine or something. So ultimately boils down to what's the probability of having more than one animation playing, because ultimately the cost is going to be the cost of how many animation you're blending together. And in the case of a blend space, usually it's three plus, depending if you're having a state machine and so on. So in comparison, what motion matching does, usually you're gonna have one or two animation. Most of cases, you're just playing one animation because you're going along the continuing pose selection. And sometimes when there are like things happening, like turns or stuff, you start blending into one or eventually a little bit more animations that you can control, by the way, the amount of animations that you have. And so ultimately it boils down where the blending of your original 3 animations is comparable with the blend of 1 or 2 animation plus the cost of building the query at runtime. Usually, at least for what we saw, we ship Fortnite with this technology on all platforms, and even very not as powerful devices. We found that the cost of building a query is roughly the same as a cost of, query plus search is roughly the cost of blending and basically using the old system. So they are roughly the same. So if you want to switch over, it's very contextual to your game, but ultimately the performance are similar in a way. It depends on the size of the data. By the way, what we did, it was on Fortnite, we're using a broader data set. Ultimately, the cost of searching that data set is proportional in a logarithmic scale, if you want to know the details, to the amount of data. And that means if you have very small data, I'm guessing is actually cheaper. But do your profiling.
Yes. Well, and speaking from the animation side, I've found it easier to use on NPCs because, at least from the animation creation sense, you can have much more complex queries for, I'm just going to use just a random example that we used in a previous game, which is interacting with a console. In an older system, you would have to go to one point where you had that one animation of the guy interacting with the console, and to build the logic of here's the 16 different ways to enter and interact with the console. Instead, it's still just interact with console, and then you throw those 16 entry animations into a motion matching database, and then it'll figure out how to get to having the NPC walk up and use that console in a nice smooth motion. Way easier using motion matching than going back and forth. I've set up guy using console in games years ago, and it takes forever. And then you're still left with something that looks very simple or rudimentary, even though you spent all this work to try to get it as smooth as possible.
Absolutely. Next question for y'all is, will there be jog animations in the future about half speed of current run animations?
So the animations that we're using now, they were captured, I could say this, they were captured for Fortnite. And so we were sort of defined, the animation speeds were already defined for us. And so we didn't have a ton of flexibility to go back and change a bunch of speeds because, again, this project was, super, it was a tight timeline. I don't know. I'd love to. So
I can answer that. No plans on the animation side. At least from my perspective, you have walk, which is at 2 meters a second. You have run, which is at 5 meters a second. Do you want something at 3.5 meters a second? That starts to get a little weird because the strafes, those are at 3.5, but now the run forward is 5. So now you have 3.5. Do you want the forward to be also 3.5? Because now you have 3.5, 3.5. Now you have to, all the different pivots are differently. How different will that be? So it's just
it's
currently there's not we have a jogging to have a jogging kind of simulator or a jogging set. No current desire, but it's not outside the realm of reason.
And also, something that we don't have in this project right now, but hopefully is coming in the future. And I know I'm saying that a lot, coming in the future. But really, I mean, we are dedicated to continue to improve this project. But stride warping a run animation so that it can move at a slower speed. That's something that we want to try to do as well, so to have that flexibility. And then, of course, there's a lot of animation packs in the marketplace. And if we did our job right, which I hope that we did, and built good tools, you should be able to use those packs in whatever way that you like. Yeah, we'll see.
Awesome. Very cool. There was someone in chat who just said jog is feature creep, can't do it.
Well, it's kind of like when you're, I mean, kind of to your point, it's like, yeah, is there a request for jog? Like, do we have like, we really need something moving forward at 3.5? That's kind of more of a game call. That's not necessarily what the project is for. Is we're not creating this will make every game for you. It's an example of how to do stuff.
Yeah, it's heavily defined by the game in which you're making and the environment that the character is moving around in.
Yeah.
And so, again, we were sort of already had our speed sort of set for us. But yeah, I mean, hopefully we'll make it easy to add new animations.
Yeah,
we'll
speaking from the, like, I've worked on games where the streaming of the level actually restricted how fast you could run forward because they didn't want you to outrun the streaming wall. And so it came down to like, your character now must move at 4.67 meters per second. It may not go 1 centimeter over. And you're like, oh, okay, so I guess we'll make it 4.6.
Yeah, perfect. All right, next up is, can I add my own animations to motion matching?
Yes. Please do. And then release them on the marketplace or something so that other people can use them.
Make cool stuff. Make lots of cool stuff.
And again, sort of going back to what Tony showed off with the root bone, if you are planning to use your own animations with motion matching, remember that the root motion data of that animation is still incredibly important. Even though we're a capsule-driven system at the moment, we still need that data so the system knows what the animation is trying to do. So just make sure that that's working well. And
to kind of soapbox for myself, when I do mocap shoots, I usually go for style, not for speed. I have worked with studios where they're just like, okay, we want the stunt actor to hit exactly 5 meters a second while running. And then you go to the stunt actor, you go, can you run at 5 meters a second exactly? And they go, maybe. And then you set up your measuring things, and you're sitting there with a stopwatch going, no, you must go slightly faster. Get the style and then use your animators or use yourself to tune that to the speeds that you need. And as long as you get the style, it's easy to adjust feet within reason. It's not like, you have a sprinting animation at 7 meters a second. It's like, now make that jog animation out of that sprint. Yeah, you're gonna look like Benny Hill.
It all comes back to the jog. That's what I'm learning.
I'm sorry, not to pick on whoever was talking about jog.
I like jog animations personally. I just like the sort of slower, more casual,
slower, deliberate motions. Like,
anyway,
which is fine. There's nothing wrong with that.
Yeah, absolutely. All right. Next question is, how can I make my character model use motion matching? Is it like retargeting of animations?
2 ways. Either offline retarget all of our animations onto your own character model using the suite of retargeting tools that are available and in the project if you want to check those out, or runtime retarget, again, using those retargeting tools, the retarget asset and the IQ rig. And there's plenty of tutorials and documentation on those tools already out there. And again, we've demonstrated that in the project as well. You can swap those characters and you can open up. And I might actually want to show this if you want to share my screen again.
Well, I mean, and also just kind of springboard out that there's a third way, which is you can do it in your own DCC tool if you want. Like, Motion Builder, you can do characterization of your character. Like, if you're more comfortable in Motion Builder, use that. There's no, you don't have to use anything. So you can just pull our animations in, characterize a character. It'd be really easy in Motion Builder, and then just apply it to your rig.
So if you open up the retarget characters folder, these are all child characters of our sandbox character, base character blueprint. And we have one animation blueprint that's just called generic retarget. And this is being applied. If I go back here, I want to open up like the echo character. So I open up the echo character. We can click on our character mesh. So the mesh, we're still using our mannequin character here, but we're making him invisible so that you can't see him. And that allows the motion matching system and all of our animation graph to still run on that invisible skeleton. And then another mesh is applied as sort of what you see in game. And so if we look at the echo body character mesh, the anim class is using a generic retarget animation blueprint. And what this animation blueprint is doing It's kind of interesting how I had to set it up. I didn't want to have to create a new animation blueprint for retargeting for all the different character types when it's effectively doing the same thing. So it is essentially using a map to grab a retargeter asset from a tag so that this character can have a tag applied to it. And I can show you that. That character mesh has a tag somewhere. Oh, wait, no, the character blueprint maybe has a tag. Oh no, I think it's the mesh. Oh boy, here we go. There it is. Have a component tag.
We got there. We got there.
And that just tells this generic retarget animation blueprint which retargeter asset to use. And then the animation graph would just have a retarget pros for mesh, and we are feeding it in that IK retargeter asset that we're setting in the event graph here from that map. And then we also have a get retarget profile. I'm just going to jump into this real quick because I know there's probably a question about it out there. This function is dynamically changing the chain settings of our retarget profile at runtime based on curves in our traversal animations, so that different sized characters can move their hands to the right position, essentially the source position or our default skeleton, so that their hands always come into contact with the world at the right spot. And I can even show you that. I don't want to get too off topic, but if I, if I do a traversal action, you see that the hands, grab onto the ledge. If I have a taller character like Twin Blast, the hands still contact the ledge, and that's all through the runtime retargeting system. We also have all of our metahuman body types here. We wanted to include that so you can see how to, how all the different metahuman body types can work as well. So this is the smallest character. You can see that they reach up and grab the ledge as well. Our largest character, they also grab the ledge. And so it's the runtime retargeting system that's doing all of that. So that was a lot, but that's how you do it. So
from
very
Gollum
cool.
to me.
It's very, very cool. Next question for y'all is, does this only work with root motion, or is there a way to do it with in-place animations as well?
So I'll take it again. Like we said, the capsule is, the character is capsule driven. It's using the character movement component to move around, but the root motion animation on that data is still incredibly vital. Without it, motion matching doesn't know what the animation is trying to do, and therefore it doesn't know if whether to pick it if the character is moving forward or not. So having that data in the animation is super important. And then if we're talking about moving the character around with root motion, all I can say is that we have plans to improve those tools. So in the future, we should hopefully be seeing something.
I want to add something on it. This
And
is
then I wanna add
actually,
something.
if you're doing a locomotion setup, yes, what Caleb said is absolutely valid. But if you're doing anything else, you want to match like just poses or something that are related to trajectory and things, no, you don't have to have root motion.
Yeah. And also just adding, the way these are animated, they're animated with both. Like if you look at it, you can turn on ignore root motions and the animation doesn't break. It shows you that they're animating in place or they're animating while moving. Both of those exist in the animation, so you can see an example of both. Because if you basically mute out the center channel, he's animating in place. I mean, and effectively that's what's happening, is he's animating in place because it's capsule driven. So it's both.
Awesome. All right. Is this all enabled, configured, and ready for multiplayer?
Tragically, not yet. And the reason is the character movement component does not replicate the acceleration channel by default. And the acceleration meaning the input acceleration applied to the character movement component, so that the velocity is one thing, the input acceleration is another thing, so the capsule moves. And that's not replicated out of the box. And we wanted to keep this a blueprint-only project so that everyone can use it, and therefore we were restricted there. However, we're also committed to making it work in a future release. So you can do it yourself if you can do code and you want to go into the character movement component and add some replication stuff in there. But that acceleration channel is pretty important for motion matching to know, or it's important for the trajectory system when the trajectory is being generated to know what is the future supposed to be. Am I supposed to be going to the left or the right? Just looking at the velocity is not enough. But all that aside, yes, motion matching is perfectly ready for multiplayer. Again, I will say, in a standard sort of multiplayer setup, animations are being calculated on the client. The server is not running those animations. So for each instance of the character on your screen, each client is doing all of this sort of motion matching animation stuff for that character. So what you see might not be exactly what another player sees, but that's currently how it is anyway. And so motion matching is really no different there. So
yeah, the only difference between what you're seeing here and let's say Fortnite is the replication of accelerations, and that's it. So Fortnite is a demonstration that this system works online, and that's the only difference. So if you have most games I saw in Unreal, they do customize the motion model and they replicate acceleration. So if you are in that condition, the answer is probably yes.
I know that there's probably a Mover 2.0 question in this as well. And just to answer that, we're looking to start using that as soon as you are. So we're excited about it. We want to start using it. The timelines of those projects just didn't line up, but in the future, we want to start using the new Mover component as well. So yeah.
Awesome. Yeah, great call. Because there was, in fact, a Mover 2.0 question.
Okay.
All right. Would love to see how weapon and item holding would work with this.
Yeah, so would we. And that's gonna we're gonna get there as well. There's a lot of work that we have to do in our layering tools to sort of apply poses to the character in ways that we can tune dynamic blend masks and all of that. And so we're actively looking into productizing some new tools. I know at the State of Unreal talk at GDC, we talked about how Fortnite used a whole bunch of new layering tools. We're hoping to productize those and release those. And when we do, we will absolutely have examples of the character holding weapons and props and all that sort of thing without having to create a whole nother data set for each thing. So I really want to do it. It should be coming in a future release.
Yeah, I'm a huge fan of not animating twice. And after working on multiple first-person shooters and having to animate the same animation twice, just in the third person and the first person, I have successfully made a first-person, third-person system that basically worked in Unreal. Yes, it was all our own stuff, but as Caleb was saying, we want to productize that and have the same thing. And it's can you do it? Yes, because I've already done it before.
Yeah. So if there's a first-person question out there, sort of that hybrid first person and truth, or what we'd call, I guess, true first person. So you
true
can
first person or first person, third person, whatever.
Yeah, we want to do it. Essentially, we're passionate about this stuff. We want to do as much as we can.
Oh,
so,
yeah.
Very cool.
And the way I built the animations is so they do support that as well. So it's not going to be now we have to redo everything. It'll be something that'll be in addition to what's already there.
Right. Yeah. Well, like you said, don't have to animate twice.
Oh, it's so annoying.
Next question is, in the traversal pose search schema, could you explain why we use the unweighted attach bone rather than the root?
I think Sam probably answered that a little, but to break it down, that attach bone, it's not necessarily getting attached to the obstacle, but what it is doing is it's allowing the motion matching system to know a bit about, it's extra data on the animation to allow motion matching to know where that animation is trying to get to. So in our traversal system, what we do is, after we get the ledge point, with our traces, we get that transform and pass it into those custom channels that Sam talked about. And so that we have that point in the world where feds into the motion matching query, and then the animations have that attach bone out there in space, so that we can compare the difference between the traversal point that we're trying to get to and all those different animations. And so it's just used in the selection process. It's also used in the motion warping process as well. Those motion warping tags on the montages for the front ledge will use that transform. So yeah, awesome. It is being used.
I also want to add one thing about it, is that you don't just need the position and orientation, but you also need the time. So if you want to use the root bone, you need to specify when. And to do that, well, you can use a notified state. We actually support a special notified state to flag events along the timeline to specify basically transform. But at that point, you have also the limitation of having the root bone to be exactly in the location where you want the character to be at that time. Well, at that point, you're limiting yourself so much that at that point it's probably better to add the new bone.
Yeah, to Sam's point, that's why we have it just in the animation, why it's stuck there the entire time, is that way you always know the difference between where your root is and where you're trying to connect. And so that you have that bit of information of over time just by having it connected all frames.
Right. Awesome. Is there any significant performance overhead on GPU or CPU to be aware of when using this approach?
I can take that. It's probably a bit more spiky. Not performance-wise. Okay, GPU, no. This is only run on CPU. Performance-wise, it depends how often you do the search, but there is like a mitigation technique, like you overlap characters, or there's also what Caleb mentioned, that is the continuing post bias, that is basically how sticky your search stays, playing basically the same animation for longer. That implies that you're searching less assets. So ultimately, I believe if the system is well tuned, it is actually more performant than normal traditional solutions, at the cost of having a little bit more spikiness in performance. That again can be mitigated by if you have multiple characters, or if you use usual strategies of how to distribute things on multiple threads.
Right. Awesome. Next question then is, oh, I lost my page. There it is. When the character
That's a
turns in the
weird
direction...
question. I'm sorry you lost your page, and I hope you find it soon.
Thank you. I appreciate that.
Oh, well, it was your question. Okay, my bad.
When the character turns in the direction of movement instead of strafe, the character feels much less precise in control, even when just running forward. What is the difference between these two modes in the demo?
Would you like to share my screen and I can show you exactly what that is?
No. Yes, we could do that, I guess.
Okay. Oh, still the metahuman. I think so. The question is, when the character is running around like this, they feel a little bit looser. There is no difference in movement or acceleration or animation. The only difference is that there's a little bit more camera lag. And so if we just want to stop updating the camera, which is the simple function that changes the spring arm parameters, if we stop updating that so that there's no camera lag, you can see it's the same. So whether we're strafing or in forward-facing movement or orient to movement rotation mode.
Yeah.
Forward-facing is sort of our internal name for when the character is always orienting toward movement, but it's really confusing because each studio has their own name for it.
It's different everywhere.
Yeah, no difference. It's just the camera. But I think that goes to show that gameplay animation is really the combination of so many different things: animation, character movement behavior, camera, all of that. So
this is also a thing that I refer to as the train conundrum when it comes to animation, which is if you've ever been on a train and then you look at the train that's like ahead of you. Sometimes you'll see it like bouncing all over the place and going crazy, and you're just like, that you're also going through that same motion because you're attached to it, but you're looking at it going, that thing's crazy. It's just because you're on the thing that you're moving. So a lot of that motion isn't perceived. So the more you change that perception of I can see this, but I'm not attached to it, the more kind of toned down and subdued. Another example is in first-person shooters. We've gotten in trouble where people have said that we've slowed down weapons, where it's literally running the exact same speed. We slowed down the frequency of how the gun swayed, so it felt a little bit more weighty, and everyone hated it because they're like, "Oh, I'm slow." It's like, well, you're running at the exact same speed, just the gun's not swinging as fast. And it's like, well, it's slow, and it's like, okay. And so we bring it back to the super fast one, and then everyone's like, "Yeah, so you fixed it." It's like, sure.
Yeah. So no change. They're the same, just the camera.
Yep.
Interesting. Very cool. Are animations like punching or sword swinging or gun holding intended for motion matching, or should we just use montages?
So, I mean, anything can be used for motion matching, not just locomotion, like we said. For the traversal system, we're picking the best entry frame based on the pose, and that might be helpful for attack animations. You can be attacking in a different direction. It's just
or in a different phase of a run.
Right. So it changes. So instead of using motion matching every frame, you can use that motion match function just to do a search at a specific point in a gameplay ability. And so for melee and stuff like that, perfectly usable. And I think we have some fun experimental stuff in the future. Sam might want to talk about. Who knows?
Yeah, I'll
just say really quick. You can have two different attacks. It's just like, say, if you have it in the phase of the run, you could have one attack that if the hand is down here, so it's like forward, you could have a backhand. Or if the hand is weird back here, you would then haul off and like do an overhead punch, and that could be the same punch, and you could do the kind of same timing, but it's just how it comes into the animation is those two different animations, and you select based on the phase on your run when you hit the attack button. You could do that motion matching. That'd be a huge pain in the butt to do elsewhere.
What we introduced at GDC was the idea of stitching. That is, you don't just match the current pose and trajectories, but you're actually trying to match also a future pose. Kind of the idea of blending from one animation to another, but instead of actually having a regular blend, you use a stitch to fill up the gaps between those two poses. So in the idea of striking, for instance, you could match a position that could be like the full strike position, and so from whatever pose your character is, you know that you're going to end up to be on a strike pose in a decided time frame. And we already have something that is implemented through the motion matching function. You see that there's, I believe it's like a future field that is where you can provide the future animation, that is animation asset at time. And we recently introduced that idea into our blend stack node that is basically just a node that allows you to blend from animation to another animation and so on, creating a stack of animations as the name implies. Where you can provide an additional database that is going to be used to search for a stitch of animation from the animation it was playing to the animation that you're requesting next, given the blend time that is no longer the blend time, is going to be replaced by the stitch of animation from the database. And it's going to come up soon as a probably production rate. Right now it's still experimental, so
right.
It may change.
So TM, little asterisk to add there.
TBD.
Asterisk,
Yeah.
TBD.
Could you explain the offset root bones translation mode and rotation mode selection process?
I could certainly try. I wish Jose was here to talk more about offset root bone. If you want to share my screen, I can sort of get into it. So like we talked about before, we have this thing called offset root bone. And if you want to see sort of what it's doing, on our handy dandy game animation widget, we have a root offset button. We can either enable or disable it and also debug it. And so by debugging it, we can actually see what the offset root bone node is doing. I forgot to change my camera back, but I guess that's fine. And so on certain animations, there might always be little discrepancies between the animation data and the movement model, even if the animation data was authored to exactly match the movement. Motion matching might enter into that animation at a slightly different frame or a slightly different time, and that's going to give you some small discrepancies. And so what the offset root bone node is doing is it's allowing the root bone to deviate just slightly based on a radius, and right now that's the red circle. It's about, I think, like, I don't know exactly how far that is, but you can see for some of these
30 centimeters.
Yeah, 30 centimeters on each side or something. So you can see for some of our start animations, you can see they don't exactly match the movement, but that offset root bone is accounting for that. In terms of selection, there's a couple of different modes. So get offset rotation mode and translation mode. So these are getter functions. So for translation, okay, I think this is sort of the meat of the question here. So we have a couple different ways in which the offset root bone can behave. And based on certain gameplay contexts, we might want different things. So if we're moving and on the ground, if we're on the ground and we're moving, we want the offset root bone to interpolate. And I don't know if there's a tooltip on this, but this just essentially means allow the root bone to deviate based on root motion, but always be interpolating it back to the center position, sort of the capsule position. Release essentially just means blend out at the offset. It's sort of, the name might not be exactly descriptive, but release is just, hey, I don't want any offset anymore. And when we're not moving, we never want the character to stand outside of the capsule for any length of time. And so if we're not moving, just release the offset. And you can see that if we have a large offset and then we stop moving, well, that was a fun bug. I don't know. I don't like. Oh, anyway. If we have, yeah. So if we have an offset and then we stop moving, you can see that the offset is quickly interpolated out. And so that's sort of what that function is doing. And so if we're falling, or if we're playing a slot animation, and that's a montage in the default slot, blend out of the offset. And similar for the rotation mode, but it's slightly different. For rotation, and I don't know how deep we're going to get into this because there's a lot we can talk about the new steering nodes that we've added. Accumulate allows the root bone to stay fixed in place so that the capsule can spin and the root will get accumulated, the rotation will get accumulated out so that the capsule can almost spin freely. And that's super helpful when we're doing stuff like turning in place or even rotational animations. Right now the character movement the character movement component doesn't have a lot of rotation control. It has very basic sort of linear rotation. And so we don't really we know that there's going to be differences, and therefore we have this offset root bone. But if we're playing a montage, well, we just want to blend out of that offset. And so that's what these functions are doing. And I know I mentioned steering, something I should probably look at, because I just realized we haven't on this stream yet, is if we double click on this motion matching node, we open up a new graph, and this is the internal graph of the motion matching system. So every new animation that motion matching selects, we are applying these things to it. So this is where we're taking care of orientation warping, which is essentially just strafe warping. I like to call it strafe warping. And we're also doing steering. And this is another experimental node where we are applying additional rotation to the animation's root motion to match a target over time. And that's what's allowing us to do sort of the turn in place animations and the rotational start animations. So we're really excited about this. And these nodes can also be used outside of motion matching in a state machine setup as well. So, so yeah, that's a little bit about the root offset system.
Very cool. Next question here is, what does pose search branch in anim notify do?
Okay, so if I open up a montage for our traversal animations, pose search branch in. Okay, so depending on the animation, we might not want all of it to be in a motion matching database. We only maybe want a couple of frames or a section of it. So for our traversal system, we only want motion matching to pick from these frames of this animation when it's doing that sort of query that we talked about earlier with the traversal system. And the pose search branch in notify state will allow you to put a section of frames into a pose search database. So
I can add a bit more details on this. So the idea is that consider that we have a function that does motion matching, and this function ultimately requires a pose search database. But the cool thing is that you can actually, instead of passing pose search database, you can just pass in straight assets. Let's say that we have a chooser that selects out of sequences or montages or whatever, and it just gives an array of those assets into the function. Now the function needs to find a way to figure out where those assets are from. Like that means what is the database that contains the index frames from those assets. If you look at this notify state, you see that one of the properties is a database. That's the database that will be used to index the frames within the interval time of that notify state. So overall, if you want to have like a brief idea, is that That notify state delimits the frames that you can use to search in from a motion matching function. Underline, that means that that tag will be populating a database index that is the one that you're seeing there, and is ultimately the one that the motion matching search will use. But this design is actually very powerful in a way that you can actually just pass in animation assets. Let's say you have a chooser again, or you have other type of assets that maybe you have a collection of assets that contains sequences or other animation assets, and you want just to search a few frames out of it. This is the way you can do that. And it's also very powerful if you want to use like backporting your old system. Let's say that you have, I don't know, like a state machine or something, and or you are using a sequence player. In the sequence players, if you're using the post search plugin, there's a flag that allows you to say use post search. What that does is that instead of starting from the frame 0 of the sequence, as it usually does, it will go through all this thing, through the notify state, and use the post search to do a selection for you. So you will not start from the frame 0, but you will start from a search frames. That means in a game that uses just sequence players, now you can use post search immediately with that.
Awesome. All right. This next question is kind of interesting, actually. I am also very curious about this. Can this system support scenarios where the capsule or character z-axis does not match the world z-axis? For example, rotating in 0 gravity, wall running, running upside down on a ceiling, etc.
Yes. So short answer, yes. Long answer is not yet, because that all comes down to the trajectory generation system. So if essentially if the character is running around a planet and like upside down, the trajectory generation needs to be able to generate that. Or while running, trajectory collision. So motion matching really doesn't care about what orientations are. It only cares about what you give it. And what you give it in sort of the locomotion context is the trajectory of the character. So if the trajectory of the character is generated properly, and we're going to be looking at improving trajectory generation in the future, then yes, it will work.
Very
So
cool.
yeah.
All right. Next up, I'm interested in understanding the unweighted attach bone and why it's needed for traversal.
I think we already got to that earlier. We went through, it's used so that the motion matching system knows what positions to compare, and also for the motion warping system.
Yep.
Awesome.
Yeah.
I have noticed an animation bug with motion matching when running against a wall or getting up a 1 meter traversal without moving. Would we be able to look at those on stream?
Yes. I saw this
Awesome.
question earlier, and when my screen was down, I went ahead and looked at it, and yes, there is indeed a bug there. So I'd love to take a look at that with you. So if you want to share my screen, we can get into it. So the first thing, character running against a wall. This was tough. Again, what I said before about trajectory generation, something that we want to do in the future is improve trajectory collision generation, so that the trajectory system knows that the character is going to be running into a wall. And right now it doesn't. We just do simple raycasts downward to get sort of the z-axis, and it's all, again, it's sort of still work in progress. Ideally, the trajectory system will be able to know that we're going to hit a wall, and sort of allow us to play animations based on that. And currently, if we're running into a wall, it's going to be orientation warping that's going to be taking care of any sort of the angle discrepancy. So that is a known bug, and that's something that we're going to be looking to improve. The root offset you can see there is sort of saying, well, I'm playing a walk animation because motion matching is telling me to play a walk animation, but my capsule is stopped. So it's trying to sort of move out from that. And all of these things can be adjusted. Root offset radius can be tightened down. Yeah, so that is a known thing that we're currently looking to improve in the future. The second bug is a little interesting. I guess we never caught it. So depending on the traversal animation, I think right there is the bug that they're talking about. One of the montages does not blend back really nice to the idle animation. So if I open up our rewind debugger, we should be able to investigate it a little bit. So let me select the character. Let me, I don't think that was the animation, that was the walking animation. So it's this one right here, right there, right. And I think I know what it is. I haven't investigated what's causing it. Let's see. So this right here is the traversal montage that we're playing at the moment. You can see traversal mantle stand forward right foot. And this is the weight of that montage. And so right about here is where we're starting to blend it out. And if we look at the, go open up our pose search window. Let me make it a little smaller here. Screen size is important. So let's see. If I tick through the frames, we should be able to see, and I'm using the arrow keys. If you click on the timeline and use the arrow keys, you can actually just go frame by frame, going forward. Okay, this is the first frame where we're going back into the locomotion setup. And oh goodness, I can't resize this. Oh, there's too many things. Okay, so we're looking at the walk loops. Okie dokie. So the chooser says that we want to be looking at the walk loops here. And my feeling is that the traversal animation is blending out a little bit too soon where there's still some velocity. And that might be causing, when we're going back to locomotion, to think that we still have the loops. So if I look at show all poses or show best asset pose, yeah, the chooser is still saying that we should be in walk loops. So if we evaluate this, go back out here, stand walks, that essentially the movement state is moving. Let me try something real quick. This is fun. I think we're going to be doing some live debugging of something that we didn't catch. And again, like we did this project on a very tight timeline, and a lot of these features came in pretty hot. So, all right, I want to stop this. So then another thing, again, with the rewind debugger, is I can go directly to the animation that's playing. So if I double click here, I could open up the montage. Okay, yep, that's what I thought. So what's happening is we have these notify states here that I created that allow us to blend out of the montages at different times based on different conditions. And if we open up this blueprint here, based on the blend out condition we set on the montage, whether we want to force it to blend out or with movement input or falling. So we can change the condition of when this montage blends out in the period that it's in this notify state. So this animation ends in an idle animation. Okay, so with movement input. Well, actually, that's weird because I don't have movement input applied here. So why would it be doing that?
I think because the trajectory is still moving. I just opened up that animation and looked, and there's a very slow, like 2-inch drift.
Yeah, but the character movement input vector should be nothing here. If I just move this back, set the early blend out. Oh, you know what it is? It's not that at all. It's the it's got to be the auto blend time. Yes. Okay. All right. I see what it is. I think we'll see. So montages have this sort of these blend out features. Enable auto blend out means that this montage will start blending out this amount of time in from the end of the animation so that it finishes its blend out before it reaches the end. That way the montage doesn't stop playing and then start a blend out. And what might be going on here is even though we have this notify state set, because we want to blend out with movement input during this time, the montage is still blending out a little bit too early. And so if I were to reduce the blend time, or the blend out trigger time dictates, well, there's a tooltip there. It always gets confusing. -1 means using blend out time. So blend out time finishes the montage ends, like I explained. If I set that to 0, the blend out will trigger when the montage hits 0. So if I save that, fingers crossed, this is actually going to work. Alrighty. Yep, bug fixed. There we go. Okay, so if you want to make that change to your asset, then yeah. So that's all it was, really, is that the montage was blending out when there was still movement in the root bone. And so as it was passing back over to the sort of the character movement component and the locomotion system, it thought that it still had movement. So for like a couple of tiny frames, the character thought that it was still moving. So yeah, that's where the bug came in.
Awesome.
And if we have time, I know we're like super over now. It's been like 2 hours, hasn't it? I'd love to talk more about how we're handling traversal blend outs back into locomotion, because that's a super fun feature that we're using motion matching with in a fun way.
So let's finish the questions first.
Yeah, I could talk all day.
Yeah.
Awesome. I mean, but yeah, if you want to, I have as much time as y'all have. So if you're up for it, I'm up for it.
Okay.
The next question that we've got here for you is, would there potentially be a monolithic pose search database that allows you to tag a pose as sparse or dense, then allow the compiler to choose which is best based on platform?
So this is an interesting topic that we've discussed, not specifically for sort of sparse versus dense, but when we were setting up this project and splitting things into a bunch of different databases, we quickly realized like workflow is not super ideal, because we might want to enable and disable just a couple of animations based on some additional gameplay context. And what we're looking to do in the future is essentially to allow us to do that. So within one database, enabling and disabling certain animations sort of at runtime based on some additional, gameplay conditions. Yeah, so I think once we have that workflow sort of set up, then it's just a matter of, tying in some LOD system based on hardware or et cetera to just sort of clear out a bunch of animations from a database from being selected or something similar. But that's a good question.
Yeah.
Yeah.
All right, so the last question that we're pulling from chat is, I haven't seen the use of dance cards. Is it better to use animation sets that feature a single locomotion behavior?
Okay. Back when I first started doing motion matching, I used dance cards because that was kind of that's what everyone said to use. What I found over the course of doing multiple motion matching systems is dance cards have some really big limitations when it comes to animation cleanup and just being able to go through your data, animate your data, and do small changes. Because if you picture you have all of your turns in one super complex dance card, which is what I did, I was like, oh, I know a way to do all turns in one shape. But then you have to take into account capturing that. So now with your stunt actor, now it's like, okay, you need to do this complex shape. You have to pivot off your left foot. You have to do it at this speed and don't screw up once. That's a tall order. And so then do you start reconstructing the dance card of, well, I like this one, except I don't like that turn. So I want this one turn at frame 30, but I don't want this other turn at frame 40. So now you have to reassemble your dance card out of different takes or constantly berate a stunt actor and make them run over and over and over and over again. And that's just, you're kind of just getting redundant data at that point. And so it just becomes a waste of time. So I've actually gone away from dance cards. I've gone back to just like figure out the motions that you want. And so I've gone to shapes. So, we have hourglass, box, prism, and diamond, and they are the different 90s 135s and stuff like that, and all their different permutations of, this is all the 135s you can do, here's all the 45s you can do, but broken into these shapes that it's really easy to capture. It's really easy for somebody to get. I don't have to like train a stunt actor for the first 2 hours of a mocap shoot to be like, okay, here's all the complex shapes, or sit halfway off the stage shouting directions, and then you get You get a performance that's basically somebody reacting to somebody yelling at them from off screen, and you can see that in the performance. You can see somebody going like, "Oh, okay, now I have to turn this. Oh, okay," or they start staring at their feet, or you have all these other problems. So it became this compound issue of like the dance cards are great in theory if I could get a Boston Dynamics robot who can just run through the dance cards and do it perfect every single time. But then why would I want to do that? Because then all of the human element gets stripped out of it. So like, why pay for mocap when it's going to be a robot doing it anyways? Just hand key it and call it good.
And the other thing
But then,
about, oh, sorry to jump in, but the other advantage of not doing dance cards is that, well, we could use these animations in whatever system we want. You don't have to use these animations for motion matching. They can go in a state machine, a blend space, etc.
Yep.
And so for us, we wanted to make sure that, we're not doing dance cards because these are template animations that can be used however users want to use them.
That's another good point. And it comes down to how do you do a dense and sparse set when all of your stuff are crammed into one dance card? Then you have to start like rating your dance cards, or then you need an entire system to strip animations that aren't being played as often, and then you're basically doing the same thing with just extra steps.
All right. Well,
so, I just don't do dance cards anymore. It's
fair enough. I think that was all the questions from chat for today. So, Caleb, I know it sounded like you had another thing you wanted to show off potentially.
Yeah, it depends on. I mean, if we still have people watching that want to see some more cool stuff.
Yeah, we do.
Yeah, how many people have bailed as I rambled along?
All right, everybody in chat, let us know who wants to see it. It's just going to be a whole line. They want to see it.
All right. So
no, stop talking.
Yeah. So more about the traversal system. If we look at some of these assets, like the mantle runs, for instance, these animations were captured with the character running, doing an action, and then going back to locomotion. And, in a traditional state machine or something like that, it might be hard to use an animation like this and get the whole tail end of it. For instance, we could set up some logic to say, like, well, if the character is currently still holding forward, then continue to play this montage. If they're not, blend out of the montage and go back to the, state machine locomotion system. And that can be kind of a nightmare. And there's a lot of animations, if you look at some of the hurdles, where we have a lot of cool motion here, where the character lands and continues to run. And we want to keep that. We don't want to never play that. And in a state machine setup, it might just become more convenient to blend out of the animation as soon as the character hits the ground and go back to the normal locomotion system. And then you lose out of all this nice follow through. And some of the animations, it's pretty detailed. We have a step where the character is sort of recovering here. But how would we use this in a convenient fashion if this animation is playing in a montage and we want to blend back to the locomotion system based on certain conditions, etc. What we did is we have a notify state here that just forces the montage to blend out. Just what the blend out condition is, force blend out. So as soon as the montage gets to this point, montage stops playing. But now what? Well, what we can do is if we open up this sequence, we can put this segment of this animation. Actually, we're putting the entire segment of this animation into a motion matching database that we are enabling from our chooser when the montage is blending out. And I will show you that in a second, but more on some of these notify states, because I think it's important that we go over these, and we didn't go over them before, and maybe we should have. But these notify states allow us to sort of filter out what frames are being used in the motion matching database and also how they're being used. So this one's self-explanatory. We're excluding these frames from the motion matching database in which this animation is put into. This notify state, block transition, I don't know if we can see the full name here. This is essentially preventing motion matching from blending into the animation in any of these frames, but allowing motion matching to continue to play these frames of the animation if this animation was already playing. So if I were to open up the, let's see if I can find it quickly. The dense, no, I think it's a run from Traversal, right? So we have a database of animations that contain the tail end of our traversal animations right here. So here's our hurdles, and here's our mantles, right? And then I think there's a little setting here. Is it in selection details or show? Display block transition. And these little debug draws, if you can see them, the green ones are the frames in which motion matching can enter this animation into. And the red ones are frames where motion matching will continue to play this animation based on the continuing pose bias, but will not enter into this animation during those frames. And so once we've got these tags set up on all of our traversal animations, we can throw these tails essentially into a motion matching database. We call this just dense stand run from traversal. And then if we open up our chooser table, we can see that when we're running and we have just traversed, I think there's some debug stuff going on here, but if we're running and we have just traversed, this condition becomes true, and then allow motion matching to select from this database, stand run from traversal. And if the trajectory and if the pose match, motion matching will play that animation just in the normal locomotion system. And I can demo that live now. And that's also how we do our land animations. We say if we've just landed, play the land animation. So if I were to do a rewind bugger tool here,
to Andrew, to answer your question, I'm not tired or something. I just have a very unfortunate looking face, and I apologize.
All right. All right. So if I were to do an action like a mantle, and I'm going to go, should update the camera again. But if I were to rewind here, you can see if we scroll down, this is where the montage plays. Okay. And that montage is mantle, run forward right foot. The montage starts blending out here. So the montage is over at this point. Montage done, back to locomotion system. But because we've enabled this database into the motion matching system, at this time, motion matching continues to play that animation. And we can see it here. We're continuing to play that animation. So we get all of this follow through really, really easily. We don't have to design a complex state machine that's like, if you're continuing to hold forward, keep playing the montage or whatever. And so I thought that was really fun. And we can see if I do some other actions here and I were to record, same deal with our hurdle animations. Scrub back. We're playing the tail end of that hurdle animation back into our locomotion system. And that's super important. Because if I were to change direction after I hit the ground, like change direction on the gamepad, I could do that, no problem. Because I'm not playing the montage anymore. Root motion's gone. I'm back to the normal locomotion system. And that keeps things, super responsive, so I can change directions immediately. I could do a mantle and then immediately start moving backwards. So yeah, that's just something I thought was really cool. It was sort of a happy accident because we did this mocap, had all these great traversal animations. And I thought, well, why don't we just throw the ends of these traversal animations into a database and enable them and see if motion matching selects them? And lo and behold, it worked. So yeah, that's about, I think, all I had to cover.
That's great. I've been renamed, so I no longer have a name.
Oh boy.
I'm just bald. I'm bald guy now. My one defining trait, my lack of follicles. Oh, I knew
God.
I shouldn't have gotten the super white light that just shines off. Oh.
Well, thank you for walking through that, Caleb. Really,
Yeah.
really appreciate you taking the extra time to give us even more cool stuff to learn about and look at. Before I release you all, I have one final question for you. Everyone who watches the show regularly knows that I always have a difficult question that I never forewarn the guests about and always leave as the last thing of the show. So you're welcome. It's a
You
little
did
bit
this.
different than normal. I did. I did it on purpose, and I
cannot
didn't
be
tell
held
you about
responsible
it.
for what I say.
So obviously, as you said, this is a living project and will continue to be added to in the future. But with that in mind, and I would love all of your thoughts on this. But for now, what are you most hoping to see come from the release of the sample?
Asset flips. Really high
Hmm.
quality asset flips. It's sort of sarcastic, but I think one of the reasons we did this is that gameplay animation is really, really hard. It takes a long time to sort of build out knowledge of how to build stuff and how to get to quality. And that knowledge is carried around from developer to different studios that they're at. And so, no studio really is guaranteed to be able to have certain developers that might have this information with them to build high quality game animation. So oftentimes, a lot of studios just struggle with it. And so I think the thing that we really just want to see is that we're raising that sort of minimum quality bar so that a student project throwing together, some stuff can take some, gorgeous looking, mega scans, get some photoreal environment, and then start with something that can match that, right? Start with quality right out of the box. And then just don't have to worry about doing the basic stuff anymore. They can move forward into, doing the fun stuff. So raising just the minimum quality bar, I think is sort of the thing I'm personally hoping to see. That felt rehearsed. I didn't.
It did feel rehearsed.
It
Wow,
wasn't.
Caleb,
It was
way to
amazing.
screw up her gotcha question.
Yeah, no,
I
it
mean,
was.
going exactly what Caleb said, I 100% agree. A lot of times when I see other people's projects, and I know I'm biased because I'm an animator, but like I'll see gorgeous backgrounds or really like cool gameplay ideas, but then the character walking around or running around, I'm just like, oh God, oh I could fix that, but I can't be everywhere, and so I just kind of wanted to, impart some of that knowledge. Is here's how I do things. It's not the right way or best way. It's just the way that I do it. That, as Caleb so put, it's like I've wandered around the industry for 24 years and figured out my ways of doing things, and I want to see what other people do with this. Like, use the animations, completely change them to something else. I've already seen people's projects of just random characters running around in the animations, and they're not detonating or exploding or look terrible. It's like, oh wow, that was, there was a couple of these were out within an hour. It's like the project shipped, and then an hour later somebody was like, hey, we slapped our character on this, and I'm like, that looks great, cool. And it's not me patting myself on the back, it's just their work applied, came together and created something different that was really nice to see.
For me, it's actually that the classical approach to animation is really populating state machine, let's call them motion graphs. The approach of motion matching is automating those transitions. That means now the development is shifting from setting up graphs manually that takes time and complexity, and ultimately the final resource of being animation is limited to something that is more like data driven, and you just dump content as a solution to your problem that is like increasing the quality and increasing the believability of your characters in a way that is 80% done there just by dumping animation into a database and see what's happening. So adding behaviors, features, and nuances to motions to make it really believable in a way is just question of adding more animation. And nowadays we know that technology is improving so fast to capture animation. Even doesn't have to be AAA quality animation. You can start with something with lower quality, just put it in so you have a very quick prototype for anybody to start with. And then once you solidify your idea, you just go and you polish it. But it's really, I know that sounds naive, but it's really democratizing the way of developing animation, developing games for everybody.
Oh, yeah, I'd love
So
to see stylized versions or something that's, not mocap, your own style, your own idea. Yeah. Pivots where you slide like your feet are on a linoleum floor. I'm a linoleum floor simulator. I'm a fan. I'll play that.
So one thing I do want to add to that as well, and I think I don't know if it was Sam that said it, but or Tony. A lot of people are searching for sort of like the right way of doing something. What is the right way of building a character locomotion system? And the truth is, there is no right way. There is no one, magic way that's going to be, it's going to work for everybody. And it took me a while to learn that. Like, starting to use Unreal, I was like, well, what's the right way of doing something? And to be honest, the right way is what works for you in the, the constraints of your project with the team that you have. However, we did feel that it was important to establish some standard and at least give people an example of a way to do something that gets good, high quality results. And so don't be too concerned. Like if you're an indie developer, working on a project, don't get too caught up in trying to figure out, okay, what's the right way of doing a combat system or the right way of doing a traversal system? Because the right way is the way that you find works for you. So yeah, I mean, that's a little bit of, I don't know.
Yeah, no, 100%, 100%. That it's just, I don't want to see my way of doing things. I want to see your way. I want to see your vision. I want to see what you think looks cool.
So please look at this project as a way. It's not, the holy grail of character locomotion systems. It's currently a way to do it with these tools, and we're going to continue to try new things and experimental stuff as well. So, yeah,
we put in something that we thought looked cool, looked fun, and it was entertaining to run around in, and it looked nice, and we enjoyed it. We're just like, oh, this is a solid version, solid way to do this. Not the only way, not the best way.
And every studio has, different ways of doing stuff. There's not many standards. You'd be surprised at, what shipped in some games. There's certain systems that were completely hacked together that shipped in from AAA, and you're like, really? Like that's how it was built, Like I'm an indie developer, and it's like I think that I would do a better job, better job at it. But so yeah, this is a way. It looks cool.
I've spent 3 months on something that to make a certain problem that I thought needed to look as good as possible, and then a game comes out years later that they just did not care. And it didn't matter. It didn't make the game any worse or better. I'm just like, how did they solve this? And I'm like, oh, they didn't.
They just didn't.
Okay. Whoops. I spent 3 months making that one weird thing work.
Amazing. All right. Well, thank you all so much for answering that question, for appeasing me with my gotcha. Appreciate it.
I didn't know that Caleb had like a scripted response, so
I only told Caleb beforehand. That's all.
Told me.
That makes a lot more sense now. Okay, I got it.
But thank you so much.
That's why Dan sent me a gotcha. Okay, got
it. Yeah, exactly. Thank you for taking the time, though, to come and speak with us and our community about this sample and walking them through it and showing them all these cool aspects of it. I'm also really personally very excited to see what they come up with and what they make with it. So thank you for, first of all, making the thing in the first place, doing the thing, but also coming to chat with us. Really, really appreciate it.
Thank you for having us.
Of course.
I'd love to come back.
Do it, please. Everyone else is already demanding that there's a second part to this stream, so I'm going to take that as a verbal handshake.
Did you change the name to just Bald Guy? I hope you did.
No. Oh, no.
He didn't? Oh, damn. Missed opportunity, sir.
In the chat, Tony Baldini. That's great.
Oh, no.
That doesn't work.
It's all devolving.
That's not even close. Come on, it's Jodini.
All right. Well, thank you also everyone who came to watch the show. It wouldn't be what it is without you and your participation and your questions. Y'all are so much fun. So thank you for taking the time to be here. If you popped in midway through, Don't worry, we post all of our streams in video format that can be viewed on demand on both our Twitch and our YouTube channel. For this one in particular, we're also going to be preserving the live chat with the VOD because Jose and Patty, big shout out to both of them yet again, were in there answering a ton of questions throughout the show as well. So make sure you go scrub through there. They had a lot of great answers in there that will also be available alongside the video itself. If you want to keep up with the latest news and all the great stuff there, you can do so on all of our socials at Unreal Engine. And if you haven't already, come join us at the Epic Developer Community, where we have our forums, we have tutorials, we have anything you could ever possibly need Unreal Engine all in one place. It's a great time. So make sure you come check that out if you haven't already. And then last thing, I guess, we can also post the link for the sample project that is now currently available in the chat. So you can go download it, play with it, fix that one bug that Caleb fixed here live for you, and let us know what you think of it. Have a good time experimenting and post all the cool things that you do with it on socials and all that good stuff. But with that, once again, thank you all so much for being here today and doing this. And for everyone else, we will see you all next time. Thanks so much, everybody. Bye.